Humanity may be on the verge of witnessing a celestial phenomenon of staggering magnitude, an event so immense that it could redefine the appearance of the night sky and remind us of the profound forces constantly shaping our universe. At the heart of this unfolding cosmic mystery is Betelgeuse, a massive red supergiant star located in the constellation Orion. Betelgeuse has always captured the curiosity of astronomers and skywatchers alike due to its brightness, color, and sheer size. However, in recent years, this star has begun to behave in ways that have raised alarm among scientists. Utilizing data from the James Webb Space Telescope, astronomers have detected strange and unexpected changes in Betelgeuse's light emissions, patterns, and structure. These developments have led experts, including physicist Brian Cox, to issue stark warnings, suggesting that what we are observing may be the final stages of a dying star. The question looming over these observations is simple, yet profound. Are we about to witness one of the rarest and most dramatic events in the observable cosmos? A supernova explosion? In the grand tapestry of the universe, stars are not static points of light. They are dynamic, complex entities that are born, evolve, and ultimately die in a variety of astonishing ways. Betelgeuse is no ordinary star. It is one of the largest and brightest visible from Earth, and plays a key role in our understanding of how massive stars evolve. Located approximately 654 light-years from Earth, Betelgeuse is a red supergiant nearing the end of its lifespan. Red supergiants represent a late evolutionary stage of stars that began their lives with many times the mass of our own Sun. Over millions of years, these stars exhaust the hydrogen in their cores, initiating a series of nuclear fusion processes that cause them to expand enormously in size while cooling on their outer surfaces. Betelgeuse is estimated to be roughly 8 to 8.5 million years old, and despite its relatively young age in cosmic terms, it is far more evolved than our Sun. This rapid progression is due to its massive size and greater energy output. The star's physical scale is almost impossible for the human mind to fully comprehend. It is approximately 900 times larger in diameter than the Sun. If Betelgeuse were to be placed at the center of our solar system, its surface would extend beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars. This incredible size also underscores the advanced stage of Betelgeuse's life. As it continues to fuse heavier elements in its core, the star is approaching an unstable state that inevitably ends in collapse. One of the most notable features of Betelgeuse is its color, which is a direct consequence of its surface temperature. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's surface is significantly cooler, averaging around 3,500 Kelvin. This lower temperature causes the star to emit light, primarily in the red portion of the visible spectrum. The red color is not just an aesthetic trait. It serves as an important clue about the star's current physical state and the types of nuclear processes occurring within its vast interior. What's particularly fascinating is that historical records suggest Betelgeuse has not always looked the way it does today. Ancient observations from Roman and Chinese astronomers indicated that Betelgeuse may have appeared yellow some 2,000 years ago. By the 9th century, Arab astronomers described the star as red. This gradual color change over centuries likely reflects the thermal and structural transformations the star has undergone as it ages. Beyond its color, Betelgeuse is also known for being a variable star. Its brightness naturally increases and decreases over time in a somewhat regular pattern. For centuries, observers have noted these variations. Betelgeuse exhibits a primary brightening and dimming cycle that spans approximately 400 days, along with a secondary cycle that lasts around 5 years. As early as 1836, Sir John Herschel documented these cycles, and there is evidence to suggest that indigenous oral traditions may have recorded this variability even earlier. However, what sets Betelgeuse apart from many other variable stars is its unpredictability. While some stars change brightness in consistent and predictable ways, Betelgeuse has shown irregular fluctuations that hint at complex, less understood processes taking place in its interior and atmosphere. This unpredictability came to a head in late 2019 when astronomers noticed a dramatic and unprecedented dimming of Betelgeuse. This event, now referred to as the Great Dimming, caught the attention of scientists and skywatchers across the globe. One of the brightest stars in the night sky began to fade rapidly, decreasing in brightness at an average rate of 0.0101 magnitude per day. By February 2020, Betelgeuse had dimmed so significantly that it was visibly fainter even to the unaided eye, a striking change from its usual prominence in Orion. For a star that has long been a familiar feature of the night sky, this sudden transformation was both disorienting and deeply intriguing. Complicating our ability to interpret these changes is the immense distance between Earth and Betelgeuse. At roughly 654 light-years away, the light we currently observe from the star actually left it around the year 1370. This delay means we are seeing Betelgeuse as it appeared centuries ago, not as it is today. As a result, even if Betelgeuse were to explode tomorrow, we would not witness that explosion until the light from the event finally reached Earth, possibly long after our lifetimes. This time lag presents a unique challenge in monitoring and understanding the real-time behavior of distant stars, reminding us of how even light, the fastest thing in the universe, carries the echoes of the past. To investigate the Great Dimming in greater detail, Dr. Andrea Dupre, Deputy Director of the Harvard-Smithsonian Center for Astrophysics, led a multi-year study using the Hubble Space Telescope. Her team closely monitored Betelgeuse's outer atmosphere, focusing on changes in the star's surface and surrounding gases. Thanks to Hubble's capacity to detect ultraviolet light, researchers were able to examine the convection processes, giant circulating cells of hot gas that drive Betelgeuse's variability. Spectral data collected at various points in 2019 and 2020 revealed that material was moving outward from the star's surface into its upper atmosphere at astonishing speeds, around 200,000 miles per hour. This expelled material eventually formed a dense dust cloud, millions of miles away from the star, which temporarily obscured its light and created the observed dimming. The mass loss from the star's southern hemisphere during this event was unusually large, about twice the normal amount. The rate at which this occurred surprised scientists, leading to speculation that the event might be more than just a typical atmospheric disturbance. The scale and speed of the mass ejection raised a critical question. Could this be a precursor to a supernova? Supernovae occur when massive stars like Betelgeuse exhaust their nuclear fuel, leading to the collapse of their cores and a resulting explosion of extraordinary energy. If Betelgeuse were to explode, it would not only be visible from Earth, but could outshine the full moon for weeks, casting shadows at night and remaining visible during the day. It would be the closest supernova observed in modern times and offer a once-in-a-lifetime opportunity for astronomers to study such an event in great detail. Yet, as exciting as this possibility is, it remains uncertain. Some researchers believe that the Great Dimming was simply a rare atmospheric event, not necessarily a sign of imminent collapse. Others argue that such an intense and rapid mass ejection could be one of the final stages before supernova detonation. Several theories have been proposed to explain Betelgeuse's behavior, ranging from surface activity driven by convective cycles to deeper structural instabilities within the star itself. The truth is that we still know relatively little about the exact mechanisms that govern the final years of supergiants. Despite centuries of observations and the advent of modern telescopes, stars like Betelgeuse continue to elude complete understanding. What we do know is that Betelgeuse remains a fascinating and unpredictable object, a celestial giant nearing the end of its long and tumultuous life. Whether it explodes tomorrow, 1,000 years from now, or not for tens of thousands of years, the story of Betelgeuse offers a vivid glimpse into the dynamic life cycles of stars and the immense forces that shape our universe. For now, all we can do is watch, wait, and listen to the signals this ancient star sends across the vastness of space, carrying with them the secrets of creation, transformation, and ultimate collapse.